And sharing my screen. First off, we're going to today look a little bit more at solving those quadratics. Homework 1.4, which has to deal with the imaginary numbers, is due on Wednesday, and homework 1.5, which deals with the quadratics, is due on Monday, and that's probably pushing the can too far down the road. I think if you could try to get that done before Monday, it would be much better. And I have to apologize. I know I just let two people in the room, and I was multitasking. Carissa, you're here?
Yes, I am.
And I have to apologize. Who else just came in? Dakaya?
Yeah, I came in.
All right. Okay. Anybody else? Okay. So I would appreciate it if you could try to get those done before that date, because that's kind of far off, and we're going to just keep on moving on with the content. So try to finish, especially this one, sooner. Should I give you guys a bribe? Should I promise extra credit if you get it done by Friday? Is that enough of an incentive or no? All right. Before we pick up from where we left off, does anybody want to look at anything from any of this chapter 1 homework, that 1.4 on complex numbers that is due Wednesday? Or has anybody started looking at any of the quadratic equations? Or does anybody still have any questions on the preceding assignment, the applications, the word problems? If not, before we pick up from where we left off, let's look at a couple of examples. We've been solving quadratic equations, and we had said that we would know that something is a quadratic if it's second degree equation in one variable. And we had outlined on Friday 3 different possible ways that we could solve them. Let's first ask you folks to please solve by factoring. And let's look at 4x squared minus 13x equals -3. And I'm going to be quiet for a minute and ask you folks to do that one. Remember, before we solve by factoring, we want to make one side 0, and then we're going to factor. Did anybody else get 1/4 and 3 as solutions?
Yep.
Yep. Does anybody need details getting from that original equation to those solutions, or are we all right? Not hearing any concerns. Next way we solved was using the square root property. And that was where if we had a quantity squared equaling a constant, we said that quantity could be plus or minus the root of the constant. So I'm going to ask you folks to solve using the square root property. 2x squared minus 7 equals negative 15. And so this time, again, we want to get that x squared by itself and then use that square root property. Did anybody else get positive 2i or negative 2i?
Yeah.
Then from there, we went on to, we finished with the idea of completing the square. And let's do a couple examples together, and then let's have you try.
Could you just go back to the last page real quick?
Sure. Did you have a question?
No, I was copying. And
Okay. What you want to do is you want to get this thing, the quantity squared alone on one side of the equal sign. And then the square root property says that, well, if x squared is equal to negative 4, then we'll take the square root of both sides and we'll say that x can equal either the square root of negative 4 or the negative square root. We have to take two roots, both the positive and the negative.
okay. Thanks.
Then solving by completing the square, let's look at an example together. Let's look at x squared plus 4x plus 13 equals 0. And if I remember correctly, to solve by completing the square, we didn't want one side to be 0, but we wanted to isolate the constant, which is a fancy pants way of saying get that plain old number alone on one side of the equal sign. So I'm going to subtract 13 from both sides, giving me x squared plus 4x, I'm going to leave a hole, equals negative 13. And then, if you recall on Friday, we said the next thing we wanted to do was to find what number had to go in that place, what would we have to add? And we're going to add the same thing to both sides to make that a perfect square trinomial. In order to do that, remember we said that we wanted the x squared to have their coefficient of 1, which we have. And once the x squared has a coefficient of 1, we're going to take that coefficient on our first degree term, the number attached to our plain old x. And can you remember we said we were going to take that number, divide it by 2, and then square it. And so 4 divided by 2 is 2. And when we square it, we get 4. And so that told me I wanted to add 4 to both sides of the equation. Does everybody remember that process from the end of the day on Friday?
Yeah.
From there, then we said that x squared plus 4x plus 4 would equal -9. But we worked real hard to make this a perfect square. That turns out to be x plus 2 squared equals -9. And again, remember that this number is whatever quantity it was that we were squaring. And now we've got something squared equaling a number. We're going to use that square root property, remembering to take both a positive and negative root. So that would give me x plus 2 equals the square root of -9, or x plus 2 equals the opposite of the square root of, sorry about that, folks, of the square root of -9. Well, we've got a negative under the radical. Remember, that means we're going to have an imaginary number. We can look at that as the square root of 9 times -1. So that gives me that x plus 2 equals 3i. And so I'll subtract 2 from both sides and get x equals -2 plus 3i. And then on the other side, this would give me x plus 2 equals, well, that's the negative of that square root, would be -3i. And so when I subtract 2 from both sides, I get x equals -2 minus 3i. And so my solutions would be -2 plus 3i, -2 minus 3i. And those are solutions that we would not get by factoring. The fact that our solutions are imaginary tells us that that quadratic was not factorable. I do not think we have ever done a check with solutions that look like this. So let's go through and let's do our check. When we check, we go back to the original. And so my original equation was x squared plus 4x minus 13 equals 0. And for x, I'm going to put in -2 plus 3i squared plus 4 times -2 plus 3i minus 13. And we're hoping that equals 0. Please remember, when we square this, we have to think of multiplying it by itself. Doing that multiplication, if I FOIL, that gives me 4 minus 6i minus 6i plus 9i squared, or 4 minus 12i. I squared is -1, so that'll be -9. Distributing here would give me -8. Whoops, I lost an I in there, I'm sorry. -8 plus 12i. And then we have the -13. And so the 12 i's cancel. And that gives me, I am off by a sign here. And, oh, I know I'm off by a sign. That was plus 13 in the original. I apologize. And so 4 minus 9 is negative 5, minus 8 is negative 13, plus 13 equals 0, and it checks. In the same way, our other root should also check if we write the equation correctly. So that would give me negative 2 minus 3i quantity squared plus 4 times negative 2 minus 3i plus 13. And we're hoping that that gives us 0. Again, here we want to think of taking that quantity and multiplying it by itself, which would give me 4 plus 6i plus 6i plus 9i squared, distributing minus 8 minus 12i plus 13. So that gives me 4 plus 12i minus 9 minus 8 minus 2i plus 13, which gives me 0, and it checks. How fun was that?
Excuse me, ma'am.
So that was our, let's remember how to do this example. Now I'm going to give you a couple of equations, and I'm going to ask you to please solve them by completing the square. Did you have a question?
Yeah, but I understand everything you did, but could you start from x squared plus 4x equals to minus 13?
Do you want me to go through the check again or the solving the equation again?
Solving the equation.
Okay. All right, when we're solving by completing the square, the first thing that we want to do is we want to take that constant term and move it to the other side. Because that's plus 13, we'll subtract 13 from both sides, and now the constant's alone. So far, so good.
Yeah.
Then remember, we had this hole here. We wanted to figure out what we had to put in there to get a perfect square trinomial. Well, in order to find that out, we looked at the x coefficient. And again, this only works if that leading coefficient is 1. Since this is 1x squared, we're going to look at this 4. We're going to take that 4, divide it by 2, and then square it. 4 divided by 2 is 2. 2 squared is, 4. So that tells me that what should be in this spot here is 4. If I add 4 to one side, I have to add it to the other side. That part all right.
Yeah.
So that gives me x squared plus 4x plus 4 equals negative 9. The reason we wanted that to be a perfect square trinomial was so that we could factor it. That factors into x plus 2 times x plus 2, or x plus 2 squared.
Okay.
Now we've got something squared equaling a constant, a number. So we take the square root of both sides. The square root of x plus 2 squared is x plus 2. So that can equal the square root of negative 9. Or remember, there's also that negative square root of negative 9. We've got two possibilities, one positive and one negative.
Okay.
Then taking that root, that gives me x plus 2 equals positive 3i on this side. So I'm going to subtract 2 and get x equals negative 2 plus 3i. On the other side, it's almost the same, except instead of positive 3i, we get negative 3i.
Yeah.
And so when we subtract the 2, we get x equals negative 2 minus 3i.
Yeah.
Better?
Yeah, thank you.
Okay. Let's have you folks try one on your own. Let's have you folks solve by completing the square. And let's look at x squared minus 6x minus 11 equals 0. And these take a while, so I'm going to be quiet, not do anything for 2-3 minutes, give you folks to try to set that up on your own. And then I'll get started, and hopefully when I'm done, you're done, and we've all got the same results. Are you folks ready to go over yet, or do you need me to be patient? Ready or no?
I'm ready.
Did anybody else get 3 plus 2 radical 5 or 3 minus 2 radical 5?
So you don't add the 3 and the 2 together?
No, because they're not like terms. Remember, to combine radicals, you have to have like terms. If I had 2 radical 5 plus 3 radical 5, they're both radical 5s, so I can change that into 5 radical 5. But
Got it.
down here, it doesn't have a radical. And you remember that order of operations says that I would have to multiply before I could add. And I'm not going to multiply that, so I can't add it. So I've got to just stop there. It's almost comparable to if it was 3 minus 2x. They're not like terms, I can't combine them. All right?
Roger.
So first, get the constant term, the plain old number, to the other side. Gives me x squared minus 6x equals 11. Now we've got to see what would we have to add in here to make a perfect square. So I'm going to take that minus 6 and divide it by 2. Gives me minus 3. When I square it, I get 9. So I add 9 to both sides. Gives me x squared minus 6x plus 9 is 20. We made sure that that would have 2 of the same factors. That would factor into x minus 3 times x minus 3, or x minus 3 squared equals 20. So now to finish solving that, we're going to use that square root property, remembering we have 2 roots, a positive and a negative. The square root of x minus 3 squared is x minus 3. That can equal the square root of 20 or the negative of the square root of 20. Hopefully everybody recognized that 20 was simplifiable. 20 can be thought of as 4 times 5, and the square root of 4 is 2. So that gives me x minus 3 equals 2 radical 5. To solve for x, we have to add 3 to both sides, and I get x equals 3 plus 2 radical 5. On the other side, that negative radical 20 would simplify into negative 2 times radical 5. I'd still have to add the 3, and it gives me x equals 3 minus 2 radical 5. Questions? Did you folks want to try one more on your own? Let's look at solve by completing the square. X squared plus 4x plus, oh, you know what? I'm going to change it up a little bit. Let's make that x squared plus 8x plus 1 equals 0. Did anybody else get x equals -4 plus the square root of 15, or x equals -4 minus the square root of 15?
Yeah, go ahead. Yeah.
I'm sorry, I can't hear you. Did you have a question?
No, I said yeah. I got it.
You got it? Great. Okay, does anybody need details or are we good? Does anybody think that this process isn't that hard, but it's a little time consuming? It can get a little bit more evil if we looked at examples where this was not an even number, and then we'd have to deal with fractions. Somewhere along the line, somebody got tired of completing the square to solve those quadratics with irrational and imaginary roots. And it led to something that was called the quadratic formula. And if you folks could humor me for 5 minutes, I promise I won't ask you to repeat the steps, but I'm going to ask you folks to help me come up with the quadratic formula by going through the process of completing the square, for ax squared plus bx plus c equals 0, where x is our variable, and a, b, and c are going to be real numbers. So completing the square, we said the first thing that we wanted to do was get that constant term alone. Here our constant term is c, so I'm going to subtract c from both sides. That gives me ax squared plus bx equals -c. We said before we filled in the blank, we wanted to make sure that the coefficient on an x squared was 1. So we're going to have to divide both sides by a. So that gives me x squared plus b over ax equals -c over a. Then we said we wanted to take half of this coefficient. So when I take that b over a, usually to take half of it, we divided it by 2. But I'm going to multiply it by a half to take half of it and square it. So that would give me b over 2a squared, which is b squared over 4a squared. So I want to add that to both sides. On the left, I'd have x squared plus b over a x plus b squared over 4a squared, which would factor into x plus b over 2a quantity squared. On the right-hand side, in order to add, I need a common denominator. So I'm going to multiply here 4a to both sides. So that gives me minus 4ac over 4a squared. Now they've got a common denominator. I can add it. I'll keep the denominator. And I'd have b squared minus 4ac in the numerator. Now when I take using the square root property, when I take the square root of both sides, I get x plus b over 2a equals either positive or negative root of b squared minus 4ac over 4a squared. But I'm going to change that a little bit. Remember to take the root of a fraction. We can take the root of the numerator over the root of the denominator. So that gives me x plus b over 2a equals plus or minus the root of b squared minus 4ac. And the square root of that denominator would just be 2a. And so now to get x all alone, I'll subtract b over 2a from both sides. And because on the right, I have a common denominator of 2a, I get x equals negative b plus or minus the root of b squared minus 4ac all over 2a. And of everything we just did, folks, this is the thing you have to remember. You need to become one with that formula. This is called the quadratic formula. And it tells us that the roots or the solutions of ax squared plus bx plus c equals 0 are x equals negative b plus the root of b squared minus 4ac all over 2a, and x equals negative b minus the root of b squared minus 4ac all over 2a. And it gives us our two roots. You have to know that. You have to remember it. There's a couple of different ways of doing that. I know if you sing it to the tune of Pop Goes the Weasel, it kind of flows. X equals negative b plus or minus the root of b squared minus 4ac all over 2a. I know there's a story, but I have to apologize. I can never remember the story. Does anybody remember the story? There was a negative boy who was unsure about whether he wanted to go out, and he decided he didn't want to be square, and he left with 4 awesome chicks, and it was all over by 2 a.m. I don't know. I don't like the story. It's kind of sexist, I think, but in any which case. Everybody, yes, no, maybe. You got to know that formula. So let's go through and let's look at how you can use that formula. So for an example, let's take that last example that we had done, which was x squared plus 8x plus 1 equals 0. And let's solve using the quadratic formula. And compare it to solve it by completing the square. The first thing that we want to do is put it in standard form. And again, that standard form is descending order, one side 0. which we've got already. It's in descending order, and one side is 0. Then we need to identify the coefficients. And these are just the coefficients. When we go through and do this part, we're just looking at the constant coefficients. We're leaving the variables behind. We want to know what A equals, B equals, and C equals. So in this example, A is the coefficient on x squared, B is the coefficient on x, C is the constant. And so since there is not a coefficient on x squared, does everybody remember that means A is 1? The coefficient on x, B is 8. The constant term, C is 1. Now we're going to write our formula that we just derived. That formula is x equals negative b plus or minus the root of b squared minus 4ac all over 2a. We're going to substitute. So that gives me x equals negative b is 8 plus or minus the square root of b is 8 squared minus 4 times a is 1, c is 1, all over 2 times a is 1. We're going to simplify. So that gives me x equals negative 8 plus or minus the square root of, let's see, 64 minus 4 is 60 over 2. Let's see, when I simplify the square root of 60, that's the square root of 4 times 15. So that gives me 2 radical 15. So that gives me negative 8 plus 2 radical 15 over 2, or negative 8 minus 2 radical 15 over 2, which gives me negative 4 plus the square root of 15 dividing, or negative 4 minus the square root of 15 as my two answers. And if I go back to when we solved that equation by completing the square, please notice that those are exactly the same solutions. And so what the quadratic formula does, because we took the time to complete the square with general coefficients A, B, and C, it gives us another method of solving these equations which are not factorable without completing the square. Let's look at, oh, no, I don't want that yet. Another example, let's solve using the quadratic formula.
I wasn't. Yeah,
Nicholas, what's up?
I was still writing that last other one.
Sorry.
All right.
Okay, so let's solve using the quadratic formula. Let's use 4x squared plus 3x equals 5. I'll leave it up to you folks. Did you want to do one more together, or did you want to try this one on your own?
Try it out. 4x squared plus 3x equals 5. 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 4x squared plus 3x equals 5.
Great. I'll be quiet. Have fun. Did anybody else get -3 plus the square root of 89 all over 8 and -3 minus the square root of 89 all over 8?
Yeah.
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 Now, did you notice that both of those last ones were irrational numbers because we had a radical left? And there's something that's referred to as finding the nature of the roots. And when I look for the nature of the roots, I look for the discriminant. And the discriminant is the radicand of the quadratic formula. which is that b squared minus 4ac. And in both those examples, we found that if the discriminant is positive, but not a perfect square, we get two irrational solutions. What we got underneath the square root symbol was a positive number that was not a perfect square. Let's look at a couple other examples and see if we can figure out what else the discriminant can tell us. Let's look at, for example, let's solve using the quadratic.
I can learn to understand you.
Oh my, sorry about that, guys. Using the quadratic formula. Let's look at 2x plus 7. You know what? No, I don't want to do that one. I take that back. Let's look at 5x squared equals 6 minus 13x. Let's do this one together. First, we need to get it in descending order with one side 0. So I'm going to subtract the 6 and add the 13x to both sides, giving me 5x squared plus 13x minus 6 equals 0. So A is 5, B is 13, C is negative 6. I'm going to substitute into x equals negative b plus minus the root of b squared minus 4ac all over 2a. Substituting, negative b is 13 plus minus the square root of 13 squared minus 4 times 5 times negative 6 all over 2 times 5 gives me negative 13 plus minus the root of, let's see, what is that? I'm going to cheat and use my calculator. 13 squared minus 4 times 5 times negative 6 gives me the square root of 289 over 10. And when I take the square root of 289, I get negative 13 plus or minus 17 over 10. With the plus sign, negative 13 plus 17 over 10 gives me I'm sorry, no it doesn't, gives me 4 over 10. Or 2/5. Negative 13 minus 17 over 10 gives me negative 30 over 10, or negative 3. And here, do you notice that we have rational roots? No radical left. And we got rational roots because what was underneath the square root symbol was a perfect square. So we get rational roots if the discriminant is a perfect square. That one, all right. Next, let's look at I'm looking for examples, and I'm not seeing examples that do what I'd like them to do. So let's look at, I'm going to add another page. Solve with the quadratic formula. Let's look at x squared plus 6x minus, I'm sorry, plus 25 equals 0. Here we're already in standard form. If I look at ax squared plus bx plus c equals 0, we get a is 1, b is 6, c is 25. And when I substitute into x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, I get negative 6 plus or minus the square root of 30b, I'm sorry, I'm skipping a step and I shouldn't. 6 squared minus 4 times 1 times 25 all over 2 times 1 gives me negative 6 plus or minus the square root of, let's see, 36 minus 100 would be negative 64 over 2. Gives me negative 6 plus 8i over 2, or negative 6 minus 8i over 2. But those would each substitute negative 3 plus 4i, or negative 3 minus 4i. And here, do you notice we got complex or imaginary solutions? And that occurred because underneath the square root symbol, we had a negative number, so that the discriminant was negative. And is everybody all right with that one?
Yeah.
Then let's look at one more. Let's solve x squared minus 18x plus 81 equals 0 using the quadratic formula. And so we're already in standard form, ax squared plus bx plus C equals 0. A is 1. B is negative 18. C is 81. And we're substituting into x equals negative b plus minus the root of b squared minus 4ac all over 2a gives me the negative of negative 18 plus or minus the square root of negative 18 squared minus 4 times 1 times 81 all over 2 times 1 gives me 18 plus or minus. Is there anybody else who wants to take over with the calculator work? 18 squared minus 4 times 1 times 81. What are you getting? Is anybody else getting 0?
Yeah.
And so I get 18 plus 0 over 2, 18 minus 0 over 2, and both of them are 9. And so the two solutions are equal to the same number if what happened? The discriminant was 0. So in terms of nature of the root, if the discriminant is 0, our two answers are the same. Backtracking a little bit. If our discriminant is negative, we get complex numbers with an imaginary part. If our discriminant is a perfect square, we get rational numbers, which means we probably could have solved by factoring. And if our discriminant is positive, but not a perfect square, we get two different irrational roots. How fun is that? So that just by looking at that b squared minus 4ac, we can tell what type of numbers we get. Now, a lot of times when you solve a quadratic equation, I guess if you're doing it in my labs, at some point in time, you can pick the method you want. If you want to try to factor first, if you want to try to use a square root property, if you want to use a quadratic formula, if you want to complete the square, most times it's up to you. I want to give you a heads up on this test. I want to know that you can do all these methods. So on this test,
Can you go to the last one?
Sure. On this test, if a question says solve by completing the square, you will not get credit if you don't complete the square to do it. You won't get full credit. If the question says solve by using the quadratic formula, you will not get full credit if you don't use the quadratic formula, and so on and so on. You're going to find that for a whole bunch of different reasons, you need to be comfortable and fluent in solving with each of those ways. So is everybody all right to solve a quadratic? There are some that you will be asked to solve by factoring. There are some that you'll be asked to solve using the square root formula. There are some that you'll be asked to solve by completing the square. And there are some that you'll be asked to solve using the quadratic formula. And again, that quadratic formula is something that you need to know, you need to memorize. Quick question. Have many of you seen the quadratic formula before?
Yeah.
Yeah. Have you derived it before? Have you seen where it came from, that completing the square with your general quadratic equation? So this is what's in that homework 1.5. But at the end of homework 1.5, there are some of everybody's favorite thing, word problems. And so I thought in the 5 minutes that remain, we could try to set up one or two word problems. I kind of just randomly took pictures of pages from the virtual textbook. So let's do one of these 5. Does anybody want to pick a number from 145 to 149? Which would you rather do?
Before that loop, I'm gonna go.
149.
149 it is. Oh, that's a fun one because it's got a picture and it's about a swimming pool. So should we put little people swimming inside the pool? Never mind. A pool measures 10 meters by 20 meters. It's surrounded by a path of uniform width, as shown in the figure below. If the area of the pool and the path combined is 600 square meters, what is the width of the path? So what they did for us here was they drew the pool 10 by 20, and they said, okay, this path is the same all the way around. So they decided in drawing this diagram that X is the width of the path. They gave us that much. Now they're saying that the area of the whole thing is 600. Well, for a rectangle, is everybody familiar with the idea that area is length times width? And let's look at these expressions that they came up with. Well, before we do that, the area we're told is 600 is equal to, let's see, this length. Well, we know that the side of the pool is 20. And you see how we're adding X on both sides. So that dimension is 20 plus 2X. And in the same way, if this dimension of the pool is 10 and we're adding X to both sides, does it make sense that that other side will be 10 plus 2X? So that's the equation we need to solve. Before we start solving it, is everybody comfortable with that being our equation?
Where did the 2 come from?
This 2 here?
Is it just because they gave you that?
No. If I'm going to go on the opposite side of the pool, if I look at this side, let me do it. If I look at this side, do you see how I've got X over here, plus the middle is 20. And then on this side, I also have another X. So I've got that side of 20, and I'm adding X on both sides. And so that's where the 2X came from. Does that make sense?
Yep.
And likewise over here, this side is 10, but I'm adding X above and below. So I'm adding those 2 X's. Now to solve it, we probably ought to put it in standard form. So I'm going to multiply out what's on the right. First would be 200. Outer would be plus 40X. Inner would be plus 20X. Last would be plus 4X squared. In descending order, that gives me 600 equals 4X squared plus 60X plus 200. I'll subtract the 600 from both sides. Gives me 0 equals 4x squared plus 60x minus 400. Now we have some choices. We can use the quadratic formula. We can complete the square. It's not really in the form to use the square root property, but we could also factor. Does anybody have a preference? I'm looking at this one, and I think I would actually like to factor it. I think it's going to be factorable because I'm thinking that those dimensions will probably be whole numbers. If not whole numbers, at least fractions. When I factor, does it jump out and bite anybody else on the nose that all 4 of those numbers are divisible by 4? Common factoring the 4 out, I get x squared minus 15x plus 100. I'm sorry. You guys yell at me. How about x squared plus 15x minus 100? Man, did I reverse those signs or what? To get x squared, it'll be x times x. Let's see, to get 100, I think if we use plus 20 and minus 5, that would give me that positive 15x in the middle. When I set each factor to 0, I know 4 cannot equal 0. I get x plus 20 equals 0, or x minus 5 equals 0. This first one, if I subtract 20 from both sides, I get x equals negative 20. The second one, if I add 5 to both sides, I get x equals 5. And I don't know of any contractors who make a side of a negative length. Since x is a distance, we're going to say that it should be 5. So now if I go and check, this side would be 10 plus 5 plus 5 would be 10 or 20. This side would be 20 plus 5 plus 5 or 10, which is 30. And the area, 30 times 20, whoops, 20, not 0, is 600. And so it checks. How fun is that? I'm looking at the clock and I'm
Yay.
thinking it's that time. So folks,